In this video, I'm going to explain how to find the angle between a line and a plane, right? So means that, of course, if the line is intersecting the plane, they will be forming an angle between the line and the plane, right? So I was using this question to explain the concepts, all right? So find the angle between this line and this plane, right? So how to find it? So I have to illustrate you by using the diagram, right? Let's say this is a plane, right? This is a plane, and this plane having this equation, and from this equation we can getting the normal vector here. So which is I, right, plus with j minus with 3k equals to 2, or we just direct take the coefficient will be 1, 1, negative 3, right? So means that this plane is having a normal vector, right? So I tell you why I need to know the normal vector, because if I want to find angle between the line and the plane, usually the direction of the plane, which is the normal, and the direction for this line will be this, right? Will be a very important information here. So means that for a plane, I have to get the normal vector, and for the line I have to get the direction vector, as these two vectors will identify the angle between the line and the plane. So now I have a normal vector for this plane, so which is the normal vector will be 1, 1, negative 3, right? So this is the normal vector. So but there is a line, right? There is a line that intersecting the plane and passing through the plane, right? So if they're passing through the plane, definitely they were making an angle with the plane, right? The angle means that if the line is passing through the plane, which is not 90 degree, it will making an angle between the line and the plane, right? The question here is to find the angle between a line and a plane, right? For example, I have a plane, right? This is my plane. So if there is a line, right? Let's say this is a line that passing through the plane, all right? Then on top, all right? So on top here, there will be a line passing through the plane, right? A line passing through the plane. If you see that this line we're making an angle, right? This is a plane and this is a line, right? The angle between this line and this plane. So which is the meaning here, right? The angle between the line and the plane, all right? So this is a straight line passing through the plane. So how to find this angle? So but we know that we need two vector, right? Two direction vector. For we have this normal vector is a direction vector also, direction of the normal, and we also have the direction of this line, right? The direction of this line we can getting from this here, right? It's a plus with tv, and v will be your direction vector. So which will be the direction of this line, right? The direction will be given as 4i 0j 1k, right? 1k. So means that the normal vector and the direction vector of the line, we can find the angle between the line and the plane. But at first we have to find this angle first. I just let this angle to be alpha. Because why? Now if I find the angle between the normal vector and the direction vector, is actually giving me the angle between the line and the normal vector. It's not the angle between the line and the plane, right? So now I have to find alpha first. Okay, normal and the direction of the line by finding the alpha. So how to find the alpha? The step here will be, I will using same thing. I will using the dot product formula. All right, magnitude of A, magnitude of B, cosine theta. But this case, this is not theta, right? This is not theta. So the angle, so I just let the theta to be alpha, right? So what is the A here, right? The A will be your N, right? It's between these two vectors, right? It's between N and V. So the vector here is N dot with V, and magnitude of N, magnitude of V, cos alpha, right? So then we're finding the N dot V, right? According to the formula, we need N dot V. So we have 1, 1, negative 3, right? 1, 1, negative 3, dot with 4, 0, 1. So we find the dot product of normal vector and the direction vector of the line. So which giving us 1 times 4, 4, plus with 0, 1 times 4, 4, 1 times 0, 0, negative 3 times 1, we have positive, negative, negative 3, so which give you 1. So it means that your n dot v is 1. Followed by, now we have the value of 1 here, finding the magnitude of n, right? So finding the magnitude of n, which is the square root of 1 square, 1 square, plus with negative 3 square, right? Square and sum all the component here. So then we can find the length of the normal vector, which gives us 9 plus 1 plus 1, 11, right? 3 square, 9, 9 plus 1, 10, 10 plus 1, 11. And followed by the direction, the magnitude of v, which will be square root of 4 square plus with 1 square, right? 4 square, 0 square, 1 square. So we're giving a square root of 16, 17, all right? So then I plug all the value here. The magnitude here will be of normal vector will be 11, and magnitude for the direction vector of the line will be 17 cos alpha. So, and we know that cos alpha can rewrite to be 1 divided by square root of 11, square root of 17. So, and finally we find the alpha first, right? The alpha will be arc cos of 1 over square root of 11, square root of 17. So then at first we get the value of alpha, all right, which were giving us 85 in 1 decimal places, 85.8 degree, all right, 85.8 degree. So this is not the angle between the line and the plane. This is the angle between the normal and the direction of the line, right? But how to find the theta here? As you know that sum of alpha plus theta, what is the value? It will be 90 degree. Do you know why? Because this is a normal vector, right? It's a normal vector. And the sum of this angle, this is 90 degree. This is 90 degree. So the angle between these two and sum up with this angle and this angle, alpha plus theta, will be 90 degree. So if you want to find the angle between the two, the angle between the line and plane, right? Between line and plane is equals to, you're taking the 90, right? 90 degree minus away. You want to find theta, you are taking 90 degree minus the alpha, right? Which minus with alpha 85.8 degree, right? 90 minus 85.8 degree, which giving 4.2 degree, right? So this is the angle between the line and the plane. So this angle is very important in physics, okay, or in any science application, especially in physics, because this telling you that the line is actually very near to the plane, all right? It's very near to the plane. It's almost touching the plane, all right? It's near the plane. So the line should be drawing such that the angle is between the line and the plane is 4.2 degree here. So I think this is the first example, and let's go for the next examples so that you have more understanding about the angle between the line and plane. Hello? Okay, let's continue with this example. So find the angle between the line and the plane. So as you know that the very important when you want to find an angle between a line and plane, plane and plane, or line and line. So means that the direction of each, let's say the plane, the direction is indicated by the normal, and the line is indicated by the direction vector. So now means that we have to get the direction of the line first, right? As we convert this to become a parametric form, so T, why I convert become parametric form, so that I can getting the direction, right? So as rearranging this, I will getting x to be -2 plus with 40 and y to be 1 plus t, right? 1 plus t. So, and your z to be 2 minus with t, right? Z to be 2 minus with t. So, alright, this is, then we can get the direction from the coefficient here, the coefficient of t. So we can very fast, we can get the direction vector, which will be 4, right? 4, 1, and -1, right? 4, 1, and -1. So after we getting the direction, then we need another direction vector, which is come from the normal. The normal here will be 3, -5, 4, right? So again, I repeat the concept here. So if we want to find angle between the line, right, the line and the plane, right, at first we should find the angle between the normal and the direction of the line, right? So then we're finding alpha first, because why? Between this is the angle between the normal and the direction vector of the line. But to find the angle between the line and the plane, right? This is the line angle between the line and the plane. So, and you know that sum up of these two will be getting 90 degree. So at first you have to find the value of alpha. So that if taking the 90 minus the alpha, you are getting the angle between the line and the plane. Alright. So first, okay, we apply the dot product, right? Assume this is your A and this is your B. The angle between the two vector, which is n dot V, magnitude of n, magnitude of V, cosine alpha, right? You know your target is finding the alpha. So n dot V, right? N dot V. So you can taking n dot with V. So I separately I doing here. So n dot with V, 3, -5, 4 dot with 4, 1, -1, right? 3, -5, 4 dot with 4, 1, -1. So then we're getting 3, 4, 12. Minus with 5, -5 times 1, -5. Negative with 4 minus 4 times -1, -4, right? 12 minus 5 minus 4. So this is -9. So giving you 3, right? 12 minus 9, which giving you 3. So, and later on we find the magnitude of n and the magnitude of v. So the magnitude of n will be 3 square plus with -5 square plus with 4 square, and the magnitude of v, the length, will be 4 square plus with 1 square plus with -1 square. Alright, okay, let's evaluate what's the value. Right, after I calculating, I getting these two value, right? And I'm going to put this into my formula. So n dot v will giving me 3, and this will be magnitude of n will be 5 square root of 2 multiply with magnitude of v, 3 square root of 2, right? 3 square root of 2 cos alpha, right? So calculate 5 square root of 2 multiplied with 3 square root of 2. So we have square root of 2 square root of 2, we're getting 2, right? Square root of 2 square root of 2, we're getting 2. 2 times with 3, 6. 6 times with 5, 30, right? 30 cos alpha, right? So later on, 3 divided by 30 is 3 divided by 30 is equals to cos alpha, and alpha will be cos of 3 divided by 30, which is 0.1. And let's find the angle, right? So which giving 84.3 degree, right? So 84.3 degree. So this is the angle, but this is the angle between the normal and the vector, right? So to find the angle, theta, right? Theta is the angle between the line and the plane, right? Between line and plane is I'm taking 90 minus with 84.3, which giving you 5.7, right? 5.7 degree. So this is the angle between this line and this plane. All right. So very simple. I've already, through the question, I'm explaining the concept of finding the angle between the line and plane. Hope you understand.